This is video 1.6, and today we're focusing on transformations of functions. And so we're going to be graphing our functions with a sequence of transformations. Now, taking everything you did on your transformation worksheet and putting it together into one big general equation, we get this equation right here that works for any function. And we'll go through it piece by piece and talk about what the different letters mean. Let's just start with a negative in the front. When you have negative times your entire function, remember that's what's going to make you reflect your graph over the x-axis. So that's going to be your x-axis flip. A negative in front of the whole thing. A negative inside the parentheses, so a negative directly next to the x, is going to be your y-axis flip, your reflection over the y-axis. When we have a value in the front here, an a in the front, so we're multiplying the whole equation by a value, so a multiplier in the front there. That is going to be your vertical stretch and compress. Now, remember, when you're stretching vertically or compressing vertically, that what you're doing is happening to the y values. Those are the ones that are going to be growing and getting smaller. The multiplier directly next to your x, so the multiplier happening directly next to the x, that's your horizontal stretch and compress. And remember, that's happening to the x values. So the x values are the ones there that will be changing. Now, it's important to remember that this is the opposite of what you normally think. So if you think that a 1/2 is going to compress the graph, it's actually going to stretch it by a factor of 2. So don't forget that that one's the opposite of what you think. Now let's talk about the things being added and subtracted. So we have our plus or minus d inside the parentheses here. The plus or minus d inside the parentheses. Remember, when it's happening directly to the x, that's what moves the graph left and right. So that's what is our horizontal shift. And this is also the opposite of what you think it should be, usually. So if you think it should move to the right because it's positive, it's actually moving to the left when it's positive. Just like when you think it's going to move to the left for negative, it's the opposite. In Algebra 2, this matched your h value. So you could also think of this d as the h value, same thing. And finally, the plus or minus e at the end, that's your shift up and down, so that's your vertical shift. And so that's what we use as our k value. In Algebra 2, we called it k. So that's the shift up and down. Now don't forget, in the front up here, we've got this f. Now that f isn't a direction, it's just our function. It's telling us what function we're talking about. Just like the x in the equation is our x value, so that's also not something that's a very going to change the way this graph looks. That's going to stay as x. So the negatives deal with the flipping, the multipliers in front and in front of the x deal with the vertical stretch and compressing, and the adding and subtracting deal with our shifting left and right and up and down. Now, with all these transformations happening, it's important that we have a order to do them in. So the order we're always going to follow, if we don't follow the same order, our graphs will look different every time. So in order to have our graphs look the same, we have to graph them in the following order. The first thing you'll do is your horizontal shifting, then your stretching and shrinking. After that, your reflecting, and finally, your vertical shift. So there's a little memory trick I had one of my students came up with to help remember. and it was the letters in the front. We start with H for horizontal, S for stretching and shrinking, R for reflecting, and V for vertical shifting. So one way you can remember, one memory trick we have is Harry sees rainbow visions. You could also come up with your own little trick. So H, S, R, V is the order we're going to do these in. Now, let's take a look at a graph, and I'm going to give you a picture here, an example. Here's a graph of a function. So the graph shown is f of x, and we want to graph the transformation 1/2 f of x minus 1. So this is the transformation we're going to be graphing. In order to do this, the first thing I would do is list out the transformations I'm going to make, and I'm going to list them out in order. So if we start with H, S, R, V, and let's see what they are. First of all, for our horizontal, do we have any horizontal shifting in this case? In taking a look here, I see a -1 inside the parentheses. So that means that's going to move this graph right 1 unit. Now we want to know about our stretching and our shrinking. And I see a 1/2 in front of the entire function. So that means that I'm going to take my y values and I'm going to multiply them 1/2. So I'm going to multiply the y's by 1/2. This is going to vertically shrink our graph or compress our graph vertically. I don't see any other multipliers there. There are no reflections happening because I have no negatives. And there's no plus or minus at the end of this function, so we have no vertical shifts either. Now that I know what I have to do, I have to move this graph right 1 and then shrink the y values in 1/2. I'm going to look at the picture and I'm going to pick some important points that would be easy to switch to move. I'm going to look for kind of on all my endpoints and my maxes and mins here. And I'm going to take all these points. If I take those 4 points and I move those 4, I can play connect the dots then and get the rest of this picture. So let's go ahead and do that now. The first thing we need to do is look at the first point. And so we'll take a look first at this point, -3, 0. I'm going to move that to the right 1 unit. Now when I move that point to the right 1 unit, it's going to end right here at -2. But we're not done yet because we have to split the y value in 1/2. Now when I take 0, the y value, and I take 1/2 of 0, it's just going to stay right here at 0. We're going to do the same thing for 3, for the point -1, 3. So we're going to take -1, 3 and first move it to the right 1, and it ends up there. But then I have to split that y value in 1/2. So when I take 3 and I multiply it by 1/2, it's going to turn into 1.5. Let's move on to the point 1, 0. Now this point is going to go right 1 and end up at 2, 0. But its y value is 0, so when I half it, it'll stay the same. And the same thing here for the point 3, 0. We're just going to move it right 1, and when I half it, it'll stay the same. And in blue, we can draw the new graph. You can see that it's the same graph. It's just shifted to the right 1 unit, and its y values are all lowered. They're all multiplied by 1/2. So it got compressed. And there's our graph. Let's go ahead and take a look at one more. We have negative f of x plus 2 minus 1, and we're going to use the same starting picture. So once again, let's list out our transformations. The first one is the horizontal shifting, and I see a plus 2 inside here, so that means this is going to go left 2 units. Now our stretching and compressing, and I don't see any multipliers there, so we have none. There's a negative in front of the entire thing, so remember that's going to be our x-axis flip. And finally, a minus 1 at the end, so that's going to be our vertical, so this graph is going down 1 unit. Now that we know what is happening here, we need to go ahead and do those things to each main point on this graph. So once again, we're going to pick those same points that we used last time, the main points on this graph. And we'll just follow the transformations for each of them. So the first thing we have to do is move this left 2 units. When I do that, that first point here is going to end up where that little x is. It's going to go from -3 to -5. I need to flip it over the x-axis. Now when I flip it over the x-axis, it's going to stay exactly where it is because it's going to flip over itself since this point is on the x-axis. And then we'll move it down 1 unit, and that's its final spot. Let's do the same thing for -1, 3. When I take that point and move it left 2, I'm going to put a little x there at -3, 3. That's where it's going to end up with left 2. Now we have to flip it over the x-axis. I'm going to count that it takes, it looks like 1, 2, 3 units to get to the x-axis. So then I'm going to go 3 more units in the other direction and put the final point there. So there's my flip. And I'm sorry, that's not going to be the final point. That's just going to be where we flipped it to. Now that we flipped it to there, we also have to shift it down 1 unit. So this looks like it's going to go 1 unit off our graph here. And so there it is. So again, let's look at that one again. We moved it 2 units to the left. We flipped it over the axes, and then we moved it down 1 unit, and that's where it ended up. We'll do the same thing for the other points as well, so we'll take 1, 0 and move it 2 units to the left, and it's going to end up here at -1. Flip it over the x-axis, it's going to stay where it is, and then down 1. It'll go here to -1, -1. And the same thing for 3, 0, we'll move it 2 units to the left, reflect it over the x-axis, it's going to stay where it is, and then down 1 unit, we'll put it right there at -1. Now that we have those points, we can connect them, and we've got our graph that has been shifted left 2 units, flipped over the x-axis, and moved down 1 unit. Now, sometimes you won't always have the function written in function notation with a picture as shown below. Sometimes you're going to be given a parent equation. So for example, this one right here, the square root of x. Now you're going to follow the same process. You'll just look for the transformations inside the function itself, and you'll use your parent graph to start with, and that will be the one you shifted. So here's your multiple choice question. I want you to use that graph to graph the square root of -x, and then I want to know which quadrant will the answer of g of x, the new function, be in. When you're finished with that and you've put it into your Google form, you have a free response question. I want to know the graph, the equation of the graph that's shown above if the original function is x squared. So I want to know basically the equation that represents those transformations. You can put that answer into your Google form as well, and then you can bring those to class tomorrow, and this is where our video will end for today.